All right, ladies and gentlemen, so in this one, we're going to introduce you to an amazing new facet, a new discovery in aeronautical engineering, a new principle. So, allow me to demonstrate my principle. So, we occasionally get fruit flies, we got some pizza boxes, some dishes. They're right next to the door where we keep the garbage outside, and I was doing this. What had just happened? Now, take a listen to this. Now, this is from the side. When I do this, there's this big flapping section. It generates a lot of wind. Traditionally, it's believed that that's why a bird flies. Same principle. From the side, there's not much wind. However, I can feel when I'm standing beside it and I start doing this that there's a little pulse of suction. I can feel it. Well, what I can also tell you is that this also works. Where I stand beside it and hit the door this way. But look at the speed the door closes. More importantly, we're going to count the flaps. Watch this, guys. This is going to be wild. We're also going to close the window so it traps more of this air. This is a revolution. Watch this. 1, 2, 3, 4, 5, 6, 7. 7 till closed. Now I'm going to do this. Open it all the way. Go to the side. Make it as stiff as I can. Now watch this. 1, 2, 3, 4, 5, 6, 7. Isn't that bloody wild? It took the exact same 7 to fully close that door. Just to the same point where it's just about against the latch. I can pull it open with a finger because it's not technically closed. It didn't do that. But what I'm seeing from this is, well, the thrust from this is slightly more. The suction from this is also enough to completely and utterly overcome the thrust being generated out the side by the wind coming off of it. When I do this, you can hear the wind. Listen close. And I can see all the stuff moving in the background. When I do this, it's more so. But there's still a fair bit of thrust being generated off the side because as I'm holding it to stiffness, the only place it's really got the stiffness is in the arch. It gathers up the air, directs it along the arch, just like a bird wing. Okay? And it catches more air that way. While at the side, the profile is vastly different. And we're not making nearly as much air. Well, if we're not making much air and the air is thrusting out this way, and I don't feel any other huge forces on it by hand when you put your hand out, what's moving the door? And then I felt what it was. And it's a moment of suction. But that moment of suction is a moment of transition when I go, it's not the actual rush of air. It's the associated vacuum moving upward that does the lifting on a bird. While the thrust for forward movement comes from this. The side way, the actual flight of a bird, we've always been able to figure... Okay, I need to background you. Because in aeronautical engineering, we've been studying the way birds fly forever, and according to the laws of physics, they shouldn't be able to. They don't make enough lift. This is why. Because we have not corrected for the suction vortex that's created as the wing swings up through the air. On the downstroke, it creates a vortex of suction on the way down, but the way they shape their wings prevents that from generating as much suction. Just like I have here, by preventing it from making as much thrust by holding it at a different angle. Same exact thing. On one, you hear the wind really strong, on one, the other less strong. It's noticeable by feeling it feels at least half. This backs it up. You would think a wind meter backs it up, but this test doesn't. This test says I actually make more suction doing it this way. Now, what's weird is when I really work at it, no matter how I do it, I can get about equal thrust, which is what's blowing my mind. I can make the straight edge of this make as much thrust as the center of this when I'm doing this. How's that possible? Off just that short straight edge. Well, it's not. It's not making that much lift. It's making that much suction through the air in terms of a vacuum. Whenever you change the pressure, you generate not only a change in pressure, but an associated vacuum with that. Well, I suggest to you that birds are shaping their wing to take advantage of this effect so that even without much thrust from a feather that's flappy, they can still generate the effect. But it's just barely enough, just like this. Whereas when you do it this way, you feel you have more than enough power to close the door. And if I do it hard enough, it's almost like I could close the door completely. But it comes just shy. Whereas when I do it from the side, no matter how hard I punch it, or like push it into it and try and really give a good grip to it, and hold it really straight and just really pound into it, the most I can do is about equal, but just shy of. It comes across just a little slower. But it takes the same number of strokes to close. It's just closing at a slight number of speed. And when I back away, I know in both cases that it's going to close all the way. Just one does it slightly faster than the other. And that's how slight a difference it really is. And that's the chill part. With half the forward thrust, it makes just shy of the same exact effect by taking advantage of its super lightweight and the vacuum generated. And the leading edge of the wing is strong and stiff. And as they flex and they force that vortex down, it's much like being in water. If you were to take your hand and let it flow gently like this, well, that's not what a bird does. It's holding it in shape with just the back ridge loose, which is what is not bad. That's what this does, because it can't hold the whole wing rigid in any one spot. There's too much flex. And at the trailing edge, there's a lot of flapping. And we tend to envision that that's where the thrust comes from. In fact, in aeronautical engineering, that's how a bird flies. But that's not the case. And so in this one, I wanted to discuss briefly the principles involved as to why that would be. Traditionally, much like an airplane, we assume it's the wind pressure difference only. But a wing doesn't flap on an airplane. And according to the rules of an airplane flying, a bird shouldn't fly, because we haven't accounted for all the variables until today. Welcome to the revolution, my friends. We're going to design a new wing together that takes advantage of a newly discovered principle that I discovered by accident in my kitchen while shooing away fruit flies. If you've ever shooted anything out the door with something like this and had the door close on you, you'll know what I mean. That power of the wind coming out the side, listen to it. It's enough for you to feel it. It's enough for you to hear it. There's significant wind there. It's more than enough to fan you and be comfortable. But it's half what you feel here. And certainly the paper in the background backs that up. For one, it barely flutters. For the other, it's gone. It went to the back of the fridge with that last one, because that's the gist of it. That's how powerful that effect of wind is forcing. The other one from the side wasn't nearly as powerful to the feel of it. To the wind, there's hardly any wind there. However, the suction generated by the vortex moving through the air with how little wind there is. Consider the following. The bird's wing has even less physical structure. Air can't pass through it. But with that, in turn, creates a larger suction and resistance through the air. They're operating on a system where they are putting out less resistance in their motion, which means there's still a really nice vortex going on, but without that little bit of suction. I think they're doing it even more efficiently than this. But even with that little bit of suction, it's not the thrust making this demonstration work. The thrust is coming off the side and off the front. And I'm not pointing that at the door. I'm pointing it out the door. And the thrust is hitting the door from the side. Watch again, watch close, guys. And you'll see that I'm not flim-flamming you. In fact, I never have, but in this one, I think it's really important that you guys get a really good view of that door. Because if you don't, it's going to be unlikely for you to just believe my ass, isn't it? So let's make it happen. So I'm just going to show you that the door is in fact open, and I'm opening it all the way, putting as much distance as I can between me and the suction. I'm also stepping over till I'm literally pressed up against the side of this. Now watch this. Look how quickly the door starts to move. This demonstration is complete, folks. See my point? You're welcome.